Hey guys, over the next few lessons we're diving into a big new topic, the C++ preprocessor. In this video I'll give you a high-level overview of what it is and how it works. In the next lesson we'll talk about preprocessor directives. After that we'll cover preprocessor operators. Alright, let's get started. Back in lesson 2, I showed you the stages of compilation. First we write our project, which consists of source files, usually with the .cpp extension, and header files, usually with the .h extension. We'll have a separate lesson on headers soon. Then we start the build process. During the first phase of compilation, a subsystem called the preprocessor kicks in. So what exactly does it do? The preprocessor doesn't understand anything about C++ semantics. It doesn't know about types, classes, verbals, or anything like that. All it sees is plain text files. It goes through a specific set of steps, and I want to walk you through them in detail. 1. BOM removal, byte order mark. A BOM is a special signature at the beginning of a file that indicates Unicode encoding. You can usually see the encoding in the bottom right corner of your code editor. We don't see the BOM directly in the code, but it's embedded in the file. In practice, for UTF-8 it looks like this, EFBBBF. The preprocessor simply strips it out so it doesn't interfere with token recognition later on. 2. Normalizing line endings. The C++ standard requires all line endings to be converted into a single internal representation. When you press enter in your code, you insert an invisible new line character. On Windows, that's usually /r/n, called CRLF. On Unix-based systems, it's just /n, called LF. Old Mac systems used /r, called CR. Again, you can usually see and even change this in your editor. The preprocessor converts all of this into one internal new line representation. 3. Handling backslash new line or line splicing. In C++, white space, spaces, tabs, new lines, is generally flexible. You can often add as much as you want. At this stage, the preprocessor handles backslash new line sequences, effectively merging lines when needed. The goal is to produce a clean, consistent character stream for further analysis. 4. Removing comments. At this point, all comments are removed because they're only for the programmer, not the compiler. More precisely, each comment is replaced with a single space. That detail matters because sometimes you rely on a comment to separate tokens. If the comment were removed entirely, you could accidentally create invalid code. 5. Splitting into preprocessing tokens. Now we enter the lexical phase of preprocessing. The raw character stream is broken down into preprocessing tokens, like identifiers, variable names, numeric literals, string literals, character literals, operators, and punctuation, like the assignment operator. Preprocessing numbers, which are a broader category than normal numeric literals, and white space. So now the text is categorized into structured token types. At this point, the raw text has been tokenized and the preprocessor can really start working with it. 6. Processing directives. A preprocessor directive is a command that starts with a hashtag followed by a keyword. You already know one directive, hashtag include, which you use all the time. There are many more, and we'll cover them in the next lesson. At this stage, the preprocessor executes those directives. For example, include literally means take the entire contents of the specified file and paste it into the current file. And 7. Macro expansion. C++ has macros, basically symbolic substitutions where one sequence of tokens is replaced with another. We've already seen one before. In lesson 38 at 11:28, I showed you the randmax macro. which defines the maximum value that function rand can return. There are tons of macros in C++, and we'll break them down in detail next time. For now, just understand that at this stage, the preprocessor scans the token stream, finds macro invocations, and replaces them with their corresponding replacement lists. That's the general idea of how the preprocessor works at a high level. In the next lesson, we'll start digging into the directives themselves. After all these steps, what we end up with is a single stream of preprocessing tokens. That's called a translation unit. And that's exactly what the compiler analyzes. Each .cpp file that goes through preprocessing becomes its own separate translation unit. Header files are typically included into other files. For example, iostream is a header file, and the preprocessor literally inserts its contents into your source file because of the include directive. So in the end, the preprocessor takes a bunch of separate files and turns them into translation units. Then the compiler takes those translation units and compiles them into object files. After that, the linker steps in, combines those object files with any required libraries, and produces either an executable file or a binary or a library file. And that wraps up the theory behind the preprocessor. Now you have a much clearer picture of how a C++ program is actually built under the hood. What's left is to go through the specific preprocessor directives available in C++, how they work, when to use them, and what built-in macros and operators the preprocessor provides. That's what we'll cover in the next few lessons. And that's it for this lesson. Thanks for watching. If you enjoyed the video, you can support me by liking it, leaving a comment, subscribing to the channel if you haven't already, donating through the link in the description, or using the YouTube thanks feature. If you want to reinforce what you learned in this lesson, you can become a channel member and get access to all the practice lessons. Just find the practice video with the same number and work through the tasks together with me. See you in the next lesson. Goodbye.